Here in this video, we are continuing with the topic of enzymes, and in this video, we'll see the factors that are affecting the enzyme's activity, and finally, we are moving towards the mechanism of action of the enzymes. So let's start the video. Okay, before explaining the factors that are going to affect the enzyme's activity, I just want you to tell me the answer in the comments that what is our body's normal temperature and blood pressure level. So if you know the answer, you can tell me in the comments. Let's see the factors that affects the enzyme's activity. So first is the substrate concentration, then temperature, and then the pH. We'll discuss them one by one. Here I'll first discuss the effect of temperature on the enzyme. So the temperature is basically doing what? It is increasing, it is enhancing the kinetic energy so that the enzyme will readily bind with the substrate. Okay, so the rate of reaction will initially increase with the increasing temperature. You can see here the rate of reaction is increasing. Okay, but once it has reached its peak, here is 40 degrees Celsius. So after the exceeding temperature, the enzyme's activity is going to fall and then it goes flat. Why? Because the enzymes bonds will break and enzymes will be denatured and it will no more be able to bind the substrate and show its activity. So just because of denaturing of enzyme due to increase in temperature, due to rise in temperature, the enzyme will not be able to produce the effect that it is gonna do. So for your information, that the optimum temperature for our body is close to 37 degrees Celsius somewhere here. So this is the maximum temperature at which the rate of reaction is excellent. Now we are going to see the effect of pH. So pH, I have mentioned here the optimum pH. Optimum pH is basically that pH where the enzyme is working best, the rate of reaction is increasing, and the pH could be acidic, neutral, or basic. So below 7 is acidic, at 7 it is the neutral pH, and then above 7 is basic pH. So different enzymes work at different pH. So if the enzyme is acidic, then the acidic pH would be the optimum pH for it. And for the neutral one and for the basic one, their optimum pH will differ. So if the pH level is disturbed, if for example the pepsin, that is an enzyme which is released in the stomach and it acts on the proteins, so it works best in the acidic pH, because in the stomach there is acidic environment just because of the production of the HCl, the hydrochloric acid. So this pepsin works best at the acidic pH. If you're gonna increase the pH below above 7, then it will be denatured, its bonds will break and the enzyme will become non-functional and it will no more be able to show its action, so the rate of reaction will be 0. So remember that the enzymes work at the optimum pH. I hope that this is clear. And I want to give you another example of the trypsin, which also catalyzes the reaction of the protein, in which the proteins break down into amino acids. So trypsin is again acting on the protein, but it cannot work in the acidic pH. It will work best in the basic pH, the alkaline pH, which is again it is above 7. So if you just put this trypsin into stomach and pepsin into the small intestine in the alkaline pH, then it will not work. They will not work in those pH because the optimum pH vary for both of these proteases. Now you'll see the substrate concentration. You can see as the substrate is coming, and it is attaching with the enzyme, the rate of reaction is increasing, it is enhancing. But after this point, the there is no effect on the rate of reaction. It is not changing. Why? Because this is the point of saturation. It means the enzyme has already been occupied by the substrate and there is no more space left for the enzyme to attach more substrate. So that's how it has become saturated. So substrate concentration also affects the enzymes, the rate of reaction, because the enzyme's activity is gonna change, because once you're increasing the substrate concentration, the enzyme is occupied, it has become saturated, so it is no more available for the other substrates that are coming. Once the product is formed and once the enzymes are free, then they are gonna bind to the substrate and then the reaction will proceed. So here the point is, like once the enzyme molecule is saturated with the substrate, they are not gonna bind the excess substrate molecules, okay, because there will be no reaction among them, between them. So I hope that this is clear, the effect of these three things: the temperature, the pH, and the substrate concentration. Now we'll see the mechanism of enzyme action. A little bit we have discussed in the previous video, but here I will discuss with you in detail. So for the enzyme to produce its action, there must be a substrate, there should be an enzyme which react together, and then they are forming the product. And here the enzyme is, by the way, acting as a biocatalyst, that is speeding up the chemical reaction. How? You can see here, this is the substrate and this is specific to a particular enzyme, so that you can say in turn that the enzyme is specific for a particular substrate. So you can see here, how is it specific? Because it has got that site to attach this type of substrate, because it has got subgeometry, okay, and it can match with the geometry of this enzyme. But you can see this active site is slightly it's slightly not matching with this shape. So the substrate's active site is flexible, so that the enzyme's active site is flexible, so the substrate can easily bind to it. What happens? The substrate binds to the active site. This way it forms enzyme substrate complex, and then the reaction is proceeding, the product is forming, still it is attached with the enzyme. So this is the enzyme product complex, and once the product has formed, it will leave this active site and they will be released by the enzyme, and they will bear their own properties, because their properties are not affected by the enzyme. This mechanism can be clear by the two models. First you'll see the lock and key model, and then you will learn about the induced fit model. So a lock and key model is basically explaining the mechanism of action of enzyme. It was presented by Emil Fischer in 1894. What does this model say? This model treats the enzyme as a lock and the substrate as a key, while this active site is acting as a keyhole. So what happens according to this lock and key model? The substrate, which is the key for this enzyme, it is gonna unlock this enzyme through the keyhole, which is the active site. So I just want to tell you the actual theory, the actual thing of this lock and key model. So this theory explains that the enzyme and the substrate possess a specific complementary geometrical shape. Like you can see, this has got a particular geometrical shape, and this has also got the particular geometrical shape, this active site. Okay, so they fit exactly into one another, like a key into a lock. So only the correct size and shape of the substrate, that is the key, would fit into active site, the keyhole of the enzyme, which is acting as a lock. But there was a little drawback, because it could not describe, this lock and key model could not describe the flexibility of the active site. So this was made by another model, which is the induced fit model. It was presented by Daniel Koshland in 1958. So According to it, the active site of the enzyme is flexible, so whenever the substrate is coming, the enzyme is gonna change, is gonna modify its shape a little bit according to the geometrical shape of this substrate, and hence it forms the enzyme substrate complex and is gonna catalyze the reaction to form the product. I hope that it is pretty clear to you the factors that are affecting the enzyme's property and the mechanism of enzyme action. And I have just mentioned the two most famous mechanism of actions theories of the enzymes, which are the lock and key model and the induced fit model. Still, if you're having any query, then you can ask in the comment. And don't forget to answer the question. You'll have to answer it in the comments. Thank you so much.